another set of video notes here talking about right triangle trigonometry. Today we're going to kind of look at part 2 of our right triangle trig section here. So far we've looked at how to set up the three trig ratios, sine, cosine, and tangent. You can see here, get a little shortcut here, sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. So if you need to, make sure you always have that right at the very top of your paper. Help you remember what sides of the right triangle you need to set up your trig ratios. So here, our main focus is how to solve for a side of a right triangle, as well as how to solve for an angle of a right triangle. Ties right in with our setups. We use those specifically, but now we just show you how to manipulate them and solve for the given piece of information that we're looking for. A couple examples here set up for you. First, we're going to take a look at how to solve for an angle. Key thing that you need to know is that you have to know two of the sides of your right triangle. So you see we've got two examples. We know two sides here, we know two sides here. If you want to take a second and pause the video to jot those down before we work through the solutions, do so now. Okay, so hopefully you've had a chance to jot these down. We've got right triangle ABC, we've got segment BC with a base of 6, and segment AB with a length of 15. So hopefully here we can solve for angles A and B. Key thing here, pick an angle to start with. Doesn't matter which angle you choose, just pick one of them. So in this case, we're going to start with angle A. So if I start with angle A, hopefully by now we've recognized that this segment will be the opposite side. This side is clearly the hypotenuse because it's directly across from the right angle. So, opposite, hypotenuse, which trig ratio is that? That's right, we're going to use the sine ratio. So the sine of A equals opposite over hypotenuse. Now, we're solving for the angle here. A is our variable, it represents the angle that we're looking for. The sine is attached to it, we need to find a way to get rid of that. On your calculators, you should notice that you've got your three trig buttons, sine, cosine, and tangent. Well, written right above those, in like actual print, not a button, but written above it, you'll see three things. You'll see sine with a -1, a cosine with a -1, and tangent with a -1. Those are the inverse trig functions. When do we use those? That's right, to find the angles. So what we're going to do here is we're actually going to take the inverse sine of the sine of A and the inverse sine of our fraction. Because whatever we do to one side, we have to do to the other. So what happens here, these two are inverses of each other, so they cancel out. And so that leaves us with just our variable, angle A. The inverse sine of 6/15, that's where you're going to need your calculator. So you put your calculator on. If you've got the calculators like we have in class, all you do is hit second, hit your sine key, then type in your ratio 6/15. Whether you use the fraction button or your division sign, shouldn't matter, but you're probably going to want to use parentheses. So we do that, and on my calculator we get a wrong answer because I'm not in the right mode. Snickerdoodles. There we go. 1. Enter that, and we come out with about 23.6 degrees. So hopefully you came out with the exact same answer. If not, either I did something wrong because my calculator's in the wrong mode, or you did. Let me double check real quick here. So I'm going to shift sine 6 divided by 15. No, 23.6 is what we should come out with. To figure out the other angle then, angle B, it's really simple. Remember, 90 degrees, which means that A and B here, our two angles, have to be complementary. So angle B, we're just going to take 90, subtract 23.6, and we should come out with 66.4 degrees, and that's angle B. Alright, if you want to, you think you can manage this one on your own, go ahead and pause the video and try it. So here again, just choose one of the two angles. This time I'm going to choose angle U. So here's my opposite. This time I've got the adjacent side. Opposite adjacent, we want to use tangent. So the tangent of U equals 17/12. Again, because we're solving for an angle, we want to use those inverses. So the tangent inverse of the tangent of U, whatever we do to one side, we do to the other. Tangents cancel out. U equals the inverse tangent of 17/12. And we come out with 54.8 degrees. Make sure you're putting your degree units in there. To solve for angle S, we're just going to subtract that from 90. And we should come out with, what do we got there? 35.2 degrees. Alright? So that's how we solve for an angle. So the last thing then left to do is solve for a side. If you want to solve for a side, two things we need to know. We need to know one of the sides of our triangle, doesn't matter which side. We also need to know one of the acute angles. We never work off the 90-degree angles in terms of our trig ratios. We talked about that in doing our setups. So, we know angle A. Obviously we can figure out angle B by just subtracting our angle measure from 90. But we're going to stick with angle A, so that makes this the opposite side. Let's solve for our hypotenuse here. So opposite hypotenuse, that gives us the sine. Well, usually we had the sine of a variable. Sine of A, sine of U, cosine of T, whatever it might have been. But here, we know what the angle measurement is. It's 42 degrees, so we can go ahead and substitute that right in. Opposite 8 over our hypotenuse. Here's where we need to apply some different strategies here. We could put this over 1, set up a proportion, and cross multiply. That would work. Or we could remember a simple little phrase, which is variable down low, division is the way to go. And so all we do is we take our variable and we swap it with our trig stuff. Okay, and so now we're dividing 8 by the sine of 42. So if I take 8 and divide it by the sine of 42, I come out with 11.95. If we round to the nearest tenth of a unit, that's going to be 12.0. The nice thing is this. Once we know that this is 12.0, we could figure out this remaining side without using trig. How would we do that? That's right, we could use Pythagorean theorem, and set up a little a squared plus b squared equals c squared and work it that way. So that's also an option for us to use. Another example here, if you wanted to jot it down real quick, go for it. Alright, so here we've got our angle measurement of 36 degrees. This is a 36. We're going to go for segment KL. So we've got adjacent, we want opposite, going to be the tangent. So the tangent of 36 equals opposite over adjacent. In this case, our variable's in the numerator of our fraction here, which is good because when the variable's up high, all you got to do is multiply. So if we just take our 10.3 and multiply it over, that's going to tell us the length of segment KL. So 10.3 times the tangent of 36, and that gives us 7.5. And then again, at that point, if we want to figure out the hypotenuse, we could do some more trig, or we could just use Pythag, whichever works out best. Alright. hope you're getting the hang of it. Pause the video, jot this one down. We're going to talk specifically about this one in class tomorrow. See how you do with it. Alright, so one last thing I want to take a look at. Kind of running down on time here. Check out the example we've got set up. We've got a solution already built here. The question is it the correct solution? Alright, we've got triangle STU. We've got angle S is 51 degrees. We've got segment ST with a base of 6 units. And so if we want to figure out the measurement of segment SU, our hypotenuse here. Alright, so here we've worked out the tangent. The question is, well, this is a great way to go. Should we be using the tangent? I know the adjacent. I want to figure out the hypotenuse. Does it make sense that it's only 6.6 units? Hopefully at this point you said, no, this is not the correct solution. Adjacent, hypotenuse, we should be using the cosine. So the cosine of 51 equals adjacent over our hypotenuse. And so again, variables down low, division is the way to go. So if we take 6 and divide by the cosine of 51, that's going to equal our variable. We're just going to switch them out. Okay, it's a swap-opportunity. And then once we divide that, we've got the length of our hypotenuse, which in this case should be 9.5. That makes a little bit more sense, I think. Alright, go back through, check in through the video if you have any other questions or if you missed something, and we'll see you guys tomorrow.